Hello everyone and welcome to Core Training Section 3, Pesticides. So during this training we're going to talk about classes and formulation, methods of application, which is very important to know how to talk to a customer regarding the types of products we use, the methods of application, and safety, how we can protect ourselves, the environment, and our customers in order to do safe application. Okay, so a little bit about the history of pesticides. Who never saw this? DDT being applied to control mosquitoes? Yes. But what is a pesticide? Let's start from there. Pesticide is any substance or mixture of substances capable of killing, attracting, repelling, regulating or interrupting the growth of mating of pests. So human beings, us, have been using pesticides for a long period of time. But the new era of pesticides actually started for urban pests in 1940s when the chlorinated hydrocarbons such as the DDT were discovered, and then began the modern era of pesticides. So they were used to control different types of pests in agriculture, urban. You can even see soldiers being sprayed on their head in certain areas of their body to control lice, ticks, right? The problem is the improper use of DDT. So it was used for everything to control every type of pest and with no restrictions of use, no thoughts on the frequency and how and where it should be applied. So we start seeing some downfalls with the DDT. In 1959, for example, it was reported the first case of DDT-resistant mosquitoes in India. In 1962, the biologist Rachel Carson wrote a book called Silent Spring that brought the issue of DDT pesticide toxicity to public awareness. So through her book, she explains how DDT had an impact on non-target organisms. For example, the bald eagle here in the United States was almost extinct because the DDT made the eggshells of this bird thinner, and then the babies would die and not hatch. Also, DDT is related to tumors in organs of mammals. It has persistence in the environment. So if I apply DDT today in a certain area, 50 years from now, I still have residues of this pesticide in the environment. So here in truly Nolen, we also have this concern about the contamination of the environment, the toxicity for our personnel, our technicians, the applicators, our customers. So we use products with low toxicity. So back to the DDT. In 1970s, it was then banned from the United States and other countries around the world, and the EPA, also known as Environmental Protection Agency, was created here in the United States for what? So this Environmental Protection Agency was created to regulate how pesticides are going to be produced, distributed. They created laws regarding the pesticide use and their residues to prevent contamination and toxicity, and cases such as this one of resistance that we talked previously with the mosquitoes. So I mentioned the term resistance. What is resistance? A lot of people talk about it, but they don't know the right concept. They say, oh, this mosquito got more resistance. No. A pest is born resistant. Okay? Resistance is the capability of a pest to live when exposed to a pesticide that was used in the recommended dose. So what does that mean? I have a pesticide here, and in the label tells me that I should be applying 10 milligrams per liter of this pesticide onto a surface. And then the pest, when it gets in contact with the pesticide, absorb it, and it doesn't die, it means that this pest is resistant. So it's not like going to the gym, like you're building up muscles, you become stronger. No, resistance, the pests are born with it. And we have two main types of resistance, such as cross-resistance, where we have pests, let's say insects, for instance, that are cross-resistant. Meaning, if I apply one group, one class of pesticides, they will not die. So they have one mechanism of defense against a pesticide that they are able to live when in contact with a class of pesticides, such as I have pests that are resistant to pyrethroids, which is a class of pesticides, a group. So they are resistant to deltametrin, cypermethrin, lambda-cyhalothrin, and many, many others belonging to that group. And then in the second case scenario, we have multiple resistance, which is more rare to occur, but it could, in which a pest, I'm going to give a practical example that's true, like German cockroaches. Some populations of German cockroaches are resistant to 2 or more classes of pesticides. So they have 2 or more mechanisms of defense against more groups of pesticides, 2 or more groups. So as I said, the German cockroaches, there are studies that show that some populations of these cockroaches are resistant to pyrethroids and phenylpyrazole, which the phenylpyrazole, the active ingredient is the fipronil. Okay, let's explain a little bit more. When does resistance happen? When a population of pests have genetic difference. So it's not that common to see resistant cases for termites and ants. Why? Because their genetic difference is very, very low. Because they have the same queen, and the babies will have practically the same DNA. It's the same queen, the same king there. So not much of a genetic difference. So pests with short life cycle and high reproductive potential are more prone for us to see cases of resistance. So pests that have short life cycle, they live, their life cycle is short, couple days, from egg to adult, short life cycle. High reproductive potential, they lay a lot of eggs, or they procreate very fast, generating a lot of descendants. Examples of common situations where we're going to find resistance is cockroaches, flies, okay, in some cases mosquitoes too. So, to make it easier for you to understand, now very simple, a case scenario here on how resistance happens. We have this video that we created in which we have an open area with several mosquitoes, and we're going to treat this area with the same pesticide over and over and over and over again. So we're going to see what's going to happen here. So I have here, as I told you before, a scenario with mosquitoes in an open area that we're going to be treating with the same pesticide over and over and over along the time, the same active ingredient, the same chemical group. And in here we have mosquitoes, the dark ones, black ones here, are considered susceptible. Those that, when in contact with the pesticide in a recommended dose, according to the label, will die. And those in red that I'm considering the resistant ones. Those that, when in contact with the pesticide used in a recommended dose, will not die. Okay, so first application, let's say, for example, I'm applying a certain chemical group of pesticide. What happens? Susceptible die, the resistant live, procreate, so they reproduce, and other mosquitoes will migrate to the area. Next week, I'll go again and apply the same pesticide. What will happen? The susceptible ones will die, the resistant will survive, they were going to reproduce, multiply, and then other mosquitoes will migrate to that area. Then the following week, I go again and spray the same chemical group, the same pesticide. The susceptible ones will die, the resistant will survive, reproduce, and then what happens? I have an area colonized only with resistant mosquitoes. Remember, guys, I'm giving an example, but that's not like that fast that resistance will occur. It could take weeks, months, years, and it's not a very frequent scenario that we're going to see in the field. It's sometimes, okay, very few times when our control is not working would be due to resistance. So, if in this case I have a population of mosquitoes, so in this area all these mosquitoes are resistant. If I apply the same pesticide, the same active ingredient, the same chemical group, what will happen? Nothing. They are not going to die. And then some people think, oh, I'm going to double the dose. No, you're aggravating the problem, because then you're going to select the super resistant ones. What should we be doing? According to the literature and some studies, we should rotate class of pesticides. So how they work on the pest. So different classes of pesticides every 3 to 6 months. That's how we do the rotation of pesticides. And if you're not getting a satisfactory level of control, I guarantee you that 99% of our cases is because you're not following truly Nolen protocols or not using the pesticide accordingly to the label, according to the label, and we're not doing the IPM. We're not using other strategies of control. We're only relying on pesticide. Remember, we have sanitation, exclusion, mechanical control, physical control, biological control, communication with the customer regarding their GMPs, the good manufacturing practices. So there are many strategies that should be used along with pesticide application. Okay, now how a pest can be resistant? How do they survive? Okay, for example, we have cases of arthropods that have higher level of pesticide enzyme, eating enzymes. So in their circulatory system, their blood, what happens? Let's say we use the pesticide that is going to interfere with their nervous system. In order to the pesticide to get to their nervous system, their brain, they have to absorb the pesticide. The pesticide will go to their blood, and in their blood they have an enzyme that digests that pesticide, and it doesn't go towards the brain. So that's how they don't die. Another situation, maybe if it is a pesticide that will act on the nervous system, their brain, maybe the pest has a different nerve junction. So their brain is a little bit different, then the pesticide won't work. Maybe they have a thicker cuticle. So the exoskeleton, their cuticle on the exoskeleton is thicker. So the pesticide doesn't penetrate their body. Pesticides. Now, please do pay attention here when we are communicating with a customer. Terminology is so important to show our professionalism. So we can divide pesticides under different categories based on, attention, it's on your quiz, how we can classify, categorize the pesticides based on what they control, their formulation, how they enter the pest body, their chemical and biological composition, and how dangerous they are. So based on what they control, when I'm talking about an insecticide, that means that this pesticide was developed to kill insects. A rodenticide, to kill, control rodents, so rats, mice. Miticide, overall in urban pest control, we don't use much miticide, but just so you know, it's a product that will control mice. Avicide, birds, but please pay attention, we don't use avicide here in Truly Nolen. We always, when a customer has an issue, an infestation with birds, we always do exclusion work. That's our approach. Okay, regarding safety of non-target animals and other issues. Larvicide, so please attention, read the label of pesticide because sometimes we have products such as the BTI, which is a biological product that kill larvae, it kills larvae of mosquitoes. So please don't use larvicides to control adults. So it's designed to kill larvae. Adulticide, same thing. It's a pesticide that is designed to kill adults of a pest. Molluscicide, mollusks such as snails, slugs. For those who don't know it, a pesticide can be formulated different ways. Just like soap. Don't we have soap in bar, soap in foam formulation, soap, liquid soap? Same thing with a pesticide. I can have a pesticide such as a pyrethroid that is a liquid formulation. That's a suspension, could be a solution, could be an emulsion. We're going to talk in details the difference between these three. It could be a solid pyrethroid. It could be a dust. It could be a granule. It could be a bait. Depending the formulation, the pesticide can be formulated different ways. Gas. These are the fumigants. Remember, we talk about those during core training 1. Only our offices that are authorized and trained with a specific certification can use the gas formulation, the fumigant. So, we have pesticides that will enter the pest of the body, enter the pest body in different ways. We have some that are ingestion products, so pesticides that the pest needs to ingest, eat to actually act on them. Examples: the gel baits for cockroaches, the gel baits for ants, the rodenticide baits for rodents. We also have baits for occasional invaders. I don't like much the terminology of stomach poison, but that's how they act. They generally will act on the midgut or even in the nervous system, but they have to be ingested. A good example, guys, of ingestion product is our borate. The borate, the DOT, that we use for crawling insects acts through ingestion. The pest needs to ingest. That's why we cannot put too much. The powder has to be on their body so they can, when they are cleaning their body, they ingest it. Contact. So there are pesticides that will act by contact through their cuticle, so their exoskeleton. Majority of pesticides that we spray will be contact pesticides. So the pest will have to stay on top of that surface that was treated to absorb the pesticide. So by contact, the pesticide will enter. Another example of contact pesticides, the diatomaceous earth, the silica gel, that will act through contact with their exoskeleton, the passing exoskeleton. And inhalation, the fumigants that will enter through, what is the name of the structure where arthropods breathe through? The spiracles. So the fumigants will enter through the spiracles of arthropods. So we also can classify pesticides based on their chemical and biological composition. So they can be salts, minerals, botanicals, synthetics, biologicals, and we're going to talk in detail a little further. And how dangerous they are. So some countries will follow the colors on the label, other countries will follow the signal words. But just so you know, here in truly Nolen, we use pesticides of low toxicity, so that are slightly dangerous or normally cause no harm. Colors on the label that you will find blue or green, and the signal word that you're going to find on the label is caution. Now, we have pesticides with higher toxicity that could be moderately dangerous, so the color on the label will be yellow, or highly dangerous, very dangerous, the color on the label will be red, such as the fumigants. So the red color, the very dangerous, the word that you're going to see on the label is danger, sometimes danger, poison. Moderately, you're going to see the word warning. Mariah, so since truly Nolen here we're working, we don't use products with high toxicity, so I don't need to use any protection equipment, right? Personal protection equipment, good. No, that's where the issue is. We always have to follow what the label requires, all the personal protective equipment and how to apply the pesticide. Because our concern is throughout the time when you're exposed to the pesticide, you can get sick. Wearing your PPE, you're not getting exposed to the pesticide that's applied, even though it's low toxicity. Throughout time, we don't want you to get sick. Okay? Now let's move to classes and formulation. So, here's the pesticide classification. We have inorganic pesticides, those that don't have the carbon in their molecule, their composition. Botanicals, plant extracts. The synthetic, those that are fabricated in laboratories. So all the molecules come from laboratories. Rodenticides, baits that will kill rodents, and the bioinsecticides, which are natural materials, so products of living beings or the living beings used to control other living beings. We're going to go there. Now, inorganic. Inorganic are the salts and minerals. Examples of pesticides that we use here in truly Nolen: borates. The borates are products that require ingestion. The pest needs to eat them so they can have an effect. Now, silica gel and diatomaceous earth, these two will act on the exoskeleton of the pest. They don't have to ingest, they act by contact. And they are abrasive pesticides, meaning that they will promote rupture of the exoskeleton, so the exoskeleton will actually break, and the arthropod will lose moisture. So the spider, the scorpion, the insect, they're going to lose moisture to the environment and die of desiccation. Okay? Desiccation is the process of losing water to the environment. A plus point here to silica gel is that silica gel also absorbs part of the moisture not only ruptures but also absorbs. Diatomaceous earth is mainly breaking up the exoskeleton. And they are slow-acting pesticides. They don't act from one day to another. And they're not considered repellent pesticides, which is a good thing, because in a lot of scenarios, we don't want to repel the pest from an area treated to an untreated area. And we're going to discuss further and further. Now back to the borates. When you look at the label of the borates we use, you're going to see the active ingredients. Active ingredients is the actual substance that kills the pest. So boric acid, disodium octoborate tetrahydrate, sodium tetraborate decahydrate. These are borates. Borates are non-repellent. So if I treat an area, the cracks and crevices, the outlet of a place, a building, right? And let's say a cockroach is there, living in that area. They're not going to migrate to other areas. They are not going to be repelled by the pesticide because it's non-repellent. The same doesn't occur when we spray, for example, with pyrethroids. Pyrethroids will repel them to other areas. So we have to explain to our customer when we are dusting for cockroaches, that's a good approach, because we don't want the issue, the infestation, to migrate to other areas of their property. That doesn't happen with the borates. Also, there aren't researches showing that resistance of, for example, German cockroaches, American cockroaches against the borates like we see for pyrethroids. And they are slow acting, which is an amazing feature of this pesticide. Why? When the cockroach, for example, eats the borate, when they're cleaning their body, ingest the dust, what will happen? They're not going to die immediately. It will take, let's say, a week and a half to actually the customer starts seeing these dead cockroaches, and that's awesome. Because when the cockroach doesn't die right away, what will happen? It will defecate, it will ingest the dust and defecate, and with the feces, with the droppings, will come out the pesticide. And who feeds on the pesticide? The nymphs of the cockroaches. So the nymphs will also get intoxicated. They're going to get contaminated by the pesticide and die. So throughout time, let's say 2 weeks, a month and a half, we're going to see the reduction or even elimination of the population of cockroaches in the customer property. Just a minor mind that borates are salts, so they can be toxic to plants. So attention there, and careful not to treat plants with borates. Now, botanicals, the plant extracts. Attention here for this name. Pyrethrum is different from the following one that we're going to see, pyrethroid. Okay, so plant extracts, we have pyrethrum and plant essential oils. Let's see the difference between these two. So for pyrethrum, also known as pyrethrins, they are extracted from chrysanthemum trees. This one, chrysanthemum flowers, as you can see here. And the active ingredients are pyrethrin 1, pyrethrin 2, cynerin 1, cynerin 2, jasmolene 1 and 2, and they are considered pesticides of low residual effect. What does it mean, low residual effect? Residual effect is the capability of a pesticide to stay acting in the environment after it was applied. So if I'm telling you that pyrethrum has low residual effect, that means that they don't stay in the environment long periods of time active. So a couple hours, depending on the the active ingredient, even minutes, they are degraded and they don't leave residue in the area treated. So, knowing that, what are the good approaches for pyrethrum? Pyrethrum, they have a wide range, meaning that they are capable of controlling several types of pests, arthropods, okay? They have a knockdown effect. They kill the pest right away, and you even see the pest shaking sometimes, the arthropod, the insect, or the arachnid. Why? Because they stimulate the nervous system. So the use of pyrethrum could be done when we're doing the Webster, removing the spider webs from the external perimeter of a building. We can apply through, there are aerosols with pyrethrum on the Webster, the equipment that we use to remove the spider webs. Another option, let's think here of a semi-enclosed restaurant. So we have an area towards the outside, the green and yellow zone. Some places they put the aerosol with a timing, so a timing misting machine where the pyrethrum is applied after a couple minutes to kill any flying insects such as flies that could be around that area. Pyrethrum can also be used in situations where we don't want to leave residue in an area treated, reducing any risk of chemical contamination. Okay? Now, plant essential oils. Overall, we don't use these as much. Examples here are the thyme oil, rosemary oil, citrus oil, linalool, lemongrass oil. They are considered more repellent, and they are considered green, natural. But attention, it's not because the product is green or natural that their toxicity is low. We have examples of formulation with rosemary oil with moderate levels of toxicity. So always read the labels, and these products will act by contact, and they're more repellent. Now, let's talk about the synthetic. A lot of pesticides we use belong to this group. Okay, so this class. Those that are manufactured in laboratories. We see three classes here that are in red, and they have an X in front. Why? Because chlorinated hydrocarbons such as DDT, chlordene, aldrin, endosulfan, linden, carbamates such as carbaryl, propoxur, benziocarb, and organophosphates, dichlorvos, chlorpyrifos, diazinon, parathion, malathion. These are highly moderate to highly toxic pesticides. And not only that, to environment, to our technicians, they build up in your body. So your body doesn't filter them, doesn't eliminate. They are kept in the fat tissues of our body. So to get intoxicated by them would be very easy. Not only that, we see sometimes, you can even look at the supermarket, some examples of pesticides, gel baits for crawling insects based on carbamates, and they are highly repellent. You're basically just wasting money because the cockroaches won't even get close to this pesticide because they're repellent. They don't attract the cockroaches, their formulation. Okay? And I'm going to give you an example of an agriculture in Brazil that he was exposed to organophosphate during applications in the field. And you know what happened to him? Over time, getting contact with the organophosphates, luckily he didn't die, but he had brain damage due to the application of and exposure to this pesticide. Because of all of these several reasons, we here in Truly Nolen are not authorized to use these pesticides that you're seeing here. Okay? Now, let's talk about the main ones that we actually utilize, that we use in our daily routine. Pyrethroids, different from pyrethrum. Pyrethrum, low residual effect. Pyrethroids, they have a longer residual effect. Apart from the first generation, resmetirom, pralitrine, cinerine, and others from first generation, they were not as long residual effect. They would be degraded by light very fast. But the newer generations, such as cypermethrin, deltametrin, cyflotrine, lambda-cyhalotrine, and permethrin, these have a longer residual effect. Pyrethroids also can be used towards different pests, different arthropods, a lot of them. It has a knockdown effect, meaning you apply, the pest get in contact with the insecticide, and it will die right away. And also is a repellent. So pyrethroids, we don't use to spray inside, guys, to control cockroaches, and we're going to see on our following training how to do that accordingly. Pyrethroids could be used, for example, in an exterior application, exterior perimeter of a building. Awesome that they are repellent. Why? Because we don't want pests getting in contact with the building, entering the building. So it's better them die outside if they get in contact with the pesticide, because they're going to be repelled by it, than entering the building. Great. Careful, because pyrethroids are highly toxic to fish. Okay, so careful when applying around lakes and river or certain areas as the property of your customer that has water, running water there. Now, pyrethroids have low solubility in water, so you have to agitate a lot when diluting the pesticide. And are a good option there, as I told you guys, to treat the green zone, yellow zone in several occasions. Now, neonicotinoids. Examples of active ingredients belonging to this chemical class: imidacloprid, thiamethoxam, acetamiprid, dinotefuran, clothianidin. These pesticides, so these active ingredients belonging to the neonicotinoids, are slow-acting pesticides. So pyrethroids kill them right away. Overall, neonicotinoids, on the other hand, are slow-acting. They don't kill the pest right away. And that's great, especially for what type of pest? Social insects. Yes, social insects such as ants and termites. It's a very good tool. Why? Because when we're controlling social insects, so ants and termites, we don't want to kill the workers, those that are walking outside of their nest. No, our objective is to kill the queen. If we're able to kill the queen, we kill the colony. So in order to kill the queen, if we don't find the nest, what should we do? We should apply a slow-acting pesticide. So apply throughout where the ants are trailing. If I see mud tubes of subterranean termites, I could apply there. So when, for example, these ants that were trailing and I applied in their trail, they're going to carry this neonicotinoid. They're not going to die, but they're going to enter the colony, and since they get in contact with other ants, passing the pesticide until reaching the queen dies, colony dies. Please do not spray pyrethroids on trails of ants because you're only killing the workers. Neonicotinoids is a synthetic version of nicotine. They are less, also present low toxicity to mammals, but they are highly toxic to bees. And in certain labels of pesticides, you're going to see that there is a specific time of the day that you cannot apply them because it's a time where bees are pollinating the trees, the plants, the ornamental plants. Okay? Now, rodenticides. Rodenticides are baits that kill rodents. So rodents will feed on this bait and die. We have mainly two groups, anticoagulants and non-anticoagulants. Overall, in our offices, we use the anticoagulants, okay, because in certain countries, the second group, a lot of countries, the second group is not accordingly, okay, it's not accepted. So, the anticoagulants are baits that will stop the coagulation of blood of rodents. What do we know about rats and mice? They have a behavior like Mariah here. They like to fight. I do my Muay Thai, my boxing. The rodents too. They're always fighting. Why? Because they want. The males, for example, will fight for the food. They will fight for the territory. The females sometimes even protecting the litter, the babies. So when they fight, what will happen? There will be internal damage to organs. And then when there is internal damage to organs, they will start bleeding. And by bleeding and eating the rodenticide, they are not going to heal and bleed to death. That's how it happens. So we have pesticides of first generation that require multiple ingestions. So the rodents need to eat several times in order to reach the dose that will kill them, such as varfarine, chlorofascinone, gifascinone, cumatetralil. And we have those of second generation that a single ingestion, once the rodents went there and ate part of that bait, it will be necessary to reach the dose necessary to kill it. So examples we have here, brodifacoum, bromadiolone, and difetialone. And how long the anticoagulants take to kill that rodent? It depends on the lethal dose, the dose that actually killed them. It could be 3 days, 5 days, 7 days, 10 days. It depends, but it's not immediate. And that's good. Why? People that think they should be using pesticides that kill the rodents right away? No. Why? Because generally, one of the colony of the rodents will actually be the guinea pig, the one that will try the bait, and the others will be looking. If that one dies, the others will not feed them from that food source. But with our rodenticide baits, they're not going to see that guinea pig rat that tried the bait to die. It will take several days. So they're not going to realize what killed that first one. And they're going to feed from the same food source. The anticoagulants, they do have an antidote, which is vitamin K1. So that's very good in cases safety-wise, because in case a child eats it or a dog eats it, there is time to save them, because it takes a long time to kill, and there is an antidote, which is vitamin K1. Okay. Now, bioinsecticides, natural materials. A good example we have is Bacillus thuringiensis, BT. There's a product called BT or BTI. That's basically a bacteria that produces a toxin, and that toxin acts on the midgut of larvae of mosquitoes and kills them. It breaks down the midgut so the larvae cannot feed and will die. And it has a very low toxicity to humans, to other animals. It's very specific to mosquitoes. So, attention is in your evaluation. Pesticides can be categorized based on their mode of action as well. So what is a mode of action? It's how a pesticide works on or kills the pest. And their mode of action could be nervous system. We have pesticides that will act on the nervous system, nerve and muscle, such as pyrethrum, pyrethroids. These first two then stimulate the nervous system. Neonicotinoids. The neonicotinoids, they prevent the transmission of information between nervous cells. So that's why the slow-acting process. The pyrethrum and pyrethroids will stimulate the nervous system. The pest will die right away, and it will be even shaking. Now, neonicotinoids, slow-acting, so they are going to stop the transmission of information from one nervous cell to another. So you're going to see the insect very slow and dying slowly, giving time for the ants and termites to bring the pesticide to the nest. Okay? We have those that will act on midgut cells, such as the BT, break midgut membranes of larvae of mosquitoes, as I just said. Others will act on blood coagulation, such as the rodenticides. They stop blood coagulation. Others will act on cell respiration, cell and energy production, desiccants. Which ones are desiccants? The silica gel, the diatomaceous earth. Okay, those two, so silica gel and diatomaceous earth, will promote loss of moisture from the body of the pest, of the arthropod. Borates, even though we know that they can act on the midgut cells, the intestine of the pest, there is also research pointing out that they can have effect on the brain, on the nervous system. Okay, so that's why they are categorized as unknown or non-specific, because it's not exactly explained how they act. And they have more than one mode of action, guys, and that's awesome. So reduces the chance of having cases of resistance in pests, as we talked previously. So when we're treating an area, we have to consider certain aspects. Let's say I'm dealing with cockroaches inside of a building. I will want a slow-acting pesticide. Why? Because I want to be able to control the whole population. I want the cockroaches to eat the pesticide, defecate the nymphs, will have time to eat those droppings with the pesticide and die as well. So we have baits with neonicotinoids, borates for them. Other scenarios. I know that certain species, we cannot control with baits, but we could use silica gel, diatomaceous earth, which are slow-acting pesticides as well. They take longer, but it's effective on control. Anticoagulants, rodenticide when we're dealing with rodents. And remember that in a lot of cases, slow-acting pesticides are less repellent. They are less repellent. In other situations, we will need a good residual. Oh, I'm applying here in the perimeter of the building, and I need a pesticide that will stay long periods of time, such as neonicotinoids and pyrethroids. Or let's say I'm treating an office area where I'm doing a preventative application, and I want the pesticide to stay there in punctual treatment, focal treatment. So I'm going to apply borates They're going to stay in cracks and crevices. If they don't get moisture, they will stay there a long period of time. Now I need a product with lower toxicity. So you're in luck, because here in Nolen we use pesticides of low toxicity. Examples: borates, neonicotinoids, pyrethrum, pyrethroids, silica gel, diatomaceous earth, and others. So I told you guys that fast kill, pesticides that promote fast kill, are generally high in repellency towards a pest. And those that promote fast kill, they can have multiple targets such as pyrethroids and pyrethrum. Versus low kill. Low kill, less repellent, and they are very good, especially for social insects, such as we even have like the borates, neonicotinoids, and for rodents, anticoagulants. Now, we're going to enter in formulations. What is a formulation? So as I told you before, just like soap, a pesticide can have different formulations. So it could be liquid, it could be solid, it could be gel. So formulation basically is the combination of an active ingredient, so it's the substance that actually kills the pest, plus an inert ingredient. It's the substance with no pesticidal activity. It's a substance that will help apply the pesticide in the area that I want to treat. It could be the diluent, it could be coloring, it could be a synergist. Sometimes we have, you can read on the label of aerosol, pyrethrum aerosol, that there is a substance called PBO, is a synergist. Is a substance that will help the active ingredient not being degraded in the body of the insect and actually have the time to act and kill the insect. So that's an inert ingredient. It's not what causes the death, but helps the active ingredient to do what it should be doing, killing the pest. Formulation also could be a diluent, or it could help the formulation to be attached to the body of the pest. Examples, we have wettable powders that contain clay, making the particle containing the active ingredient bigger and easier to be carried through arachnids such as scorpions and spiders. So the combination of active ingredient and inert ingredient is what we call formulation. We have formulations for dry applications such as the dusts. Dusts are very useful in case scenarios where we cannot apply liquid application. So in outlets, conduits, cracks and crevices when we're dealing inside application, they're very useful and they stay long period of time acting. For example, our borates. But please, when applying borates, apply the minimum necessary quantity. What I mean, 1 puff. Because if we apply too much, it is hygroscopic. It absorbs the humidity of the environment and it loses its capability of getting attached to the body of the insect. Baits. Baits is what we consider the most safe formulation. Why? The rodenticide baits will be always inside of devices with a key to lock, preventing other animals to get in contact and chemical contamination of the environment. Baits is a combination of an attractive, like a food attractive, plus the insecticide. We have also gel baits for insects, for crawling pests that we can apply in small quantities and in hidden areas. So that's why they're so safe. Pellets, we have also some options of pellets when we're treating outside of the building especially. Granular, so granular formulations generally we use in the green and yellow zone outside of the building, and we don't have as many options of granular pesticides. I'm not talking about granular bait. I'm talking about granular pesticides. So what happens is they're good to penetrate different layers of the vegetation, and they need to act with water. They need the water to infiltrate in the soil, and they can be absorbed by the plants, actually killing some insects that way throughout the plant. But careful with granular, because granular, if you apply in orchards and areas where they have fruitiferous trees, it shouldn't be the most advisable approach. Okay? Granular, but not granular bait. Bait you can apply according to the label. Formulation for liquid application. So we have basically 3 types of liquid application. We have solutions, which are not as common for urban pest management. So that they are the ones that mix perfectly with water. So if you look after you dilute the pesticide, you're going to see under a microscope a perfect mixing between the pesticide and the water. They're what we call soluble powders. They have small particles, they don't leave residue, but they degrade very fast. Suspensions. These are very common. We use in different formulations. So suspensions are crystals or capsules suspended in water. So we could have, after we mix the pesticide, we do the mix, they could become crystals or they could be capsules that are diluted in our mix. Okay, so suspensions, all of these ones here, so suspension concentrates, wettable powders, water dispersible granules, aerosols, dry flowables, and microencapsulated, they require frequent agitation. So when I'm going to do the mix, I always advise to put water, if you're just diluting water, so you put the water first, a little bit, then you add the pesticide, and then you fill until the volume you need with the rest of water and agitate. And then throughout your application, you should be agitating the mix. Because they decantate, the particles can decantate to the bottom of the sprayer, so we want to avoid that. So those suspensions that form crystals, we have the suspension concentrates that they don't leave as much residues on the surface treated, and their crystals are smaller than when we compare with wettable powders. Okay, so they're good for smooth surfaces when we're treating them in different scenarios. But if we're dealing with surfaces that have a lot of pores, they're not very smooth, a lot of pores in the surface, we are going to advise using what? The wettable powder, water dispersible granules, dry flowables, or even the microencapsulated, because they have bigger particles and they don't, majority of the pesticide will be on top of the surface treated, and it will be very easy for the pest to carry it on their body. Also, wettable powders. Let's start with wettable powders. These 4 that actually I just said, wettable powders, water dispersible granules, dry flowables, and microencapsulated, they're very recommended, especially for arachnids. Remember what I told about the difference about insects and arachnids? They're very useful because it's easier for the arthropod to carry through their leg because they have bigger particles containing the active ingredient. It's easier to attach to the body of the arachnid. Careful with wettable powder. So if you see on the label that this pesticide is a WP, it needs to be diluted in water. Do not apply as a dust. Okay, the concentration will be extremely high. Come on, read the label. Also careful because the WP, WDG, and DF, they leave residue on the surface treated. So careful with areas that has access to the public. If you're treating, for example, in a school, we don't want the kids playing around and get in contact with that wall that was treated. Situations like that, maybe a suspension concentrate would be the best option. Or treat other areas. Now, water dispersible granules and dry flowables are basically the same as wettable powders, but they come in, they're not dust, so the risk of inhalation is lower than the wettable powders. Aerosols, when you are applying the ready-to-use pesticides, generally come in a can. Pay attention where it's spraying, and if the wind, according to the wind, not against it, so you don't want to backing up to you, and always wear the mask and all the PPEs required on label because there is a risk of inhalation. Microencapsulated. Man, these formulations are very, very high-tech. They generally are a little bit more expensive than the others. Why? Because with the active ingredient stays inside of a polymer like a plastic capsule. Very tiny, microscopic, but it's big in comparison to other suspensions and solutions and emulsion. So they stay longer periods of time on the surface treated. Let's say, for example, I have a pyrethroid that it is a suspension concentrate and I treat an environment. That pesticide may stay 30, 40 days acting, but when we apply a microencapsulated, it could stay there for 45, 60 days because the capsules will protect the active ingredient against the UV light, which is one of the main ones that will degrade the pesticide, and the active ingredient will be liberated slowly, and also the microencapsulated pesticides reduce the odor of the pesticide being applied. Now, let's talk here about emotions. Not emotions, emotions. Emotions are oil suspended in water, what we call emulsifiable concentrates. You're going to see on the label this abbreviations, EC or E. So emulsions, there is a high risk of absorption through the skin of the applicator when we're applying emulsions. The particle, so the oil particle containing the active ingredient is very, very small, the particle with the active ingredient. So they are not good to treat surfaces. If my objective is for the pesticide to stay on top of a surface, emulsions is not the answer. Because majority of the pesticide will be absorbed through the wall, for example, that you treated. So the pest will have to stay on top of the surface long period of time to actually absorb the dose that will kill it. So emulsions is a very good formulation for when we want the pesticide to be absorbed through the surface treated. For example, for dry wood termites, when we're treating wood, EC will be very good option. Careful with emulsions because they're also phytotoxic, meaning they can be toxic to plants. I've seen before people applying emulsions in ornamental plants, and next thing you know, customer is calling, hey, my plants are all yellow. What happened here? We burned the plant. It's toxic to it. So always read the label and the recommendations. Okay? And emulsions can be also corrosive to the sprayers, the equipment, the application equipment. And here I'm going to give you guys an advice of what we always should be doing. Every day after we do our applications, please rinse your equipment, rinse the sprayers. Don't leave pesticides inside of the sprayers from one day to another or even from 1 week to another. Why? Because that pesticide inside of the sprayer will be clogging the nozzle, for example, will be corroding will be corrosive to the rubber parts. So we want to avoid that and give a longer durability to the equipment. Sometimes I catch technicians when they have a nozzle, the tip of the sprayer that's blocked. I see them blowing the tip like this. It's clogged. Don't do that. It is clogged because you did not rinse your equipment. By doing that, you're ingesting pesticide or getting dermal exposure. Your skin is exposed to that pesticide. Don't do that. But then, there is the smart one, right? So you're going to I'm going to do like Mariah. I'm not going to blow the tip of the sprayer. So I'm going to use this clip and I'm going to clean the tip. Don't do that. You know why? Because if you use that clip to clean the nozzle of the sprayer, you're damaging the diameter of that opening. Because the size of the diameter of the nozzle, the hole, is important to create the correct size of the droplets to treat specific areas. And if you damage that size, what will happen? Next thing you know, your sprayer is leaking because you damaged it. So now you guys know better. Formulation used for fumigation. We have compressed liquid and solid formulations that liberate gas, that have high capability of penetrate the material treated, but they could be explosive and they can kill people. So be very careful. As I said before, only authorized offices and trained offices with a certification can do this type of service. Now, back to our formulations, all of them. How formulations can be degraded? By time. Every product will have an expiration date, correct? Water. Areas that we have rain. Let's say your customer is washing a kitchen. If you know that area is always washed, why are you going to apply pesticide there? Apply in other areas, preventing the pesticide to be washed out. If it is a rainy day, I cannot do the service, Mariah. We always will find cracks and crevices in areas where pests are harboring that we could treat. And please be mindful to not treat an area in rainy days, because it could be washed out and your application was the same thing as nothing. So be attentive to that and where you could be applying the pesticide, at least in rainy days. The water can rinse it out. And UV light. Now, which are the formulations that degrade quicker? They have a smaller particle, the aerosols, right? The solution, so soluble powder, suspension concentrate, the emulsions, emulsifiable concentrates. They have smaller particles, so they don't last as long. They degrade quicker. And how formulations can be degraded slower? Which ones? Dust. If the dust, the borax that we apply don't get humidity, they can stay long periods of time acting in that area. Granules, pellets, baits, microencapsulated, wettable powders, water dispersible granules. So these three, they have a bigger particle, and the microencapsulated also have a capsule that protects the active ingredients. so they degrade slower. Methods of application. Okay, guys, so when we are preparing a proposal, when we're talking to a customer over the phone or in person, be mindful of how we use our terminology. We're not doing fumigation to cockroaches. No. Fumigation is the use of gas. We could do what type of treatment for cockroaches there? A spot treatment. Spot treatment, I'm treating an area of less than 2 square feet. When we use the terminology of broadcast application, broadcast treatment, we're treating large surfaces. So I could be treating the whole green zone, yellow zone. When we do broadcast application, for example, for mosquitoes, for ticks, for fleas, they are good examples of broadcast application. Space treatment, I'm treating the air in that room. So when we use the aerosol, thermonebulization, UVL application, ultra low volume application, okay? Nebulization, these are types of space treatment. Barrier. When do we do chemical barrier, guys? For subterranean termites. So, barrier treatment. For treatment of the external perimeter of the building, I'm doing a barrier treatment. Treatment of cracks and crevices. We do a lot for crawling insects. Okay? Fumigation, there you go. Then we're talking about fumigation in cases some offices could do for termites, for instance. Few offices. Pre-baiting and trapping and removal. We do that strategy, and you are going to see in the following training for rodents. We pre-bait, trap, and remove them from interior areas. Baiting, we could do for rodents, we could do for crawling insects. Okay, baiting. Now, application equipment. We have, during our inspection, we have to use what? Our mirror of inspection, that we're going to see a video about it afterwards, and our flashlight. During the actual application of pesticides, when we are applying gel, I really like to see technicians with the bait gun. It looks like a Western movie, like, right? The bait gun is very important to put the necessary amount of pesticide in the area that should be treated. So we know that bait, the gel bait, should be applied in small portions, in cracks, crevices, or hidden places, and can be used around electronic devices. Please do not apply the borates, the dust, inside of electronic devices. Why? Because they absorb moisture, humidity from the environment. And what water does to TVs, computers, they damage them. So let's say your customer has an infestation of ants inside of a computer, or even cockroaches in electronic equipment. You could apply bait around that device without damaging it. It's an option. Apply small amount of bait where it needs to go, and avoid applying it near hot places. Why? Here's a conceptual mistake that sometimes could happen. We don't use bait, the gel bait, as preventative measure of control. If your customer does not have an infestation, don't apply the gel bait, because once the gel bait dries out, which will take a day or two, the pest won't feed off that dry bait. Okay? So, if you're not seeing that the bait is being consumed, if there is no activity, don't apply. And don't apply near hot places because it will dry out very fast. And, as I said, Apply small portions. Don't apply a line of gel. You're applying way more than necessary. Read the label, you're going to see one droplet is more than enough to treat that area. Okay? Dusters. Dusters should be your best friend. What are the main jobs that we do? A lot of jobs that we do is for crawling insects. And what do we do inside of the facility to control crawling insects? We apply dust and cracks and crevices. So we have here the hand duster. Remember, the less is better. If you're applying the dust, one puff is enough to treat that specific area. Some people like to do, one for me, one for the pest, one for to guarantee. And then what happens? You have a thick layer of dust. That will not work because that dust will get the humidity of the environment and cake up. And there you go, your cockroach walking through the dust. And the ants not catching on their body because it's caked up. It's not a fine dust anymore that will attach to their body. You're just using pesticides and not in an efficient way. And never broadcast dust. If some of the dust fell in an area that should not be treated, get your paintbrush that you should have as one of your equipments of application. Get that rest of dust that fell in an area that shouldn't be treated and put back in a crack or crevice or area that should be treated. That way, the paintbrush will also will be more effective during the application. Okay? Quart hand duster. When we want to treat larger areas such as attics, behind equipment that we don't have access, we could use a quart hand duster to treat with a larger amount of pesticides, of the dust. Sprayer. So we have the manual sprayer. That's generally our aerosol can. So we activate by hand, by our fingers. So that's a manual sprayer. The backpack. The backpack is used for liquid applications and in some cases that you're going to see, foam applications. Compression sprayer. The compression sprayer, we apply the pressure before the application. So we put pressure and then we do the application. Power sprayer. Power sprayer we use when larger quantities, larger amounts of pesticides are needed to treat, for example, the green zone for subterranean termite treatment, and they are attached and hooked up to the truck. Now, let's talk a little bit about our label and safety data sheet. All of our technicians and personnel that deal with pesticides, let's say you're an admin person that takes care of the inventory and the pesticides in the office, you should know and read all the labels of pesticides that are in your office. And technicians, supervisors, we always read the label. And where do we find the information on how to use a pesticide? Attention, where? On the label. It's not asking our co-worker, hey, how do I do the dilution of the demand here? If your co-worker is doing wrong, the message will get to you and you're going to do wrong as well. So always read the label. And what do we see in the label? A commercial name. So in this case, we use as an example demand. CS, the formulation. CS, what is CS? Capsule suspended. It's a microencapsulated formulation. Okay? We have the active ingredient. So in this case, lambda cyhalothrin. When it finished with thrin is a pyrethroid. So we have the active ingredient and other ingredients. We have the signal word, caution. So this product has lower toxicity. Based on the word here, I can already tell. And it's a group 3 insecticide. We're going to talk what does that mean when we get to the toxicity part of this presentation. It has the EPA registration. Each country will have their own agency to regulate the use of pesticides. In some countries will be still EPA, other countries will be other ones. The volume, it has the first aid information, precautionary statement, environmental hazard, physical and chemical hazard. So here we have directions for you. So how to use the pesticide in different areas, for example, structure and perimeter pest control, how to do the mixing, right? And it tells you which pests this pesticide can be used to control. Sometimes, I know the pyrethroid will kill these spiders, but we have to check if the label is telling that it's one of the target pests, okay? If it's not, you cannot use. And be mindful that sometimes you're going to see that in our protocols, even though your provider will tell you, oh, this product is awesome to control the cockroaches, pay attention, because it's not because the pesticide can kill the cockroach. In certain areas will not be the most advisable one. That's why we do the trainings, so you know how to follow the protocols and guarantee safety and control. So you can tell from the label that there's a different concentration depending on the pest, depending on the area that's going to be treated. Okay, so it's important that all of our personnel that manage and use pesticides to read the label. Okay, so here we have for different pests how to utilize the demand, how to do the treatment in different areas. The rate of application, and warnings. Do not use this product with oil. Let treated surfaces dry before allowing humans and pests to contact surfaces. Why? Because while still wet, is liberating what? Organic vapors that can be inhaled, and also thermal exposition. So we want to avoid that. How to do the dilution. And remember that majority of pesticides that we're spraying it will be required to wear gloves, masks with the correct filters, even goggles, sometimes long sleeves. So we will always have to read the label for those information. Also on the label, we're going to find the storage and disposal on how to dispose the pesticide, the container after use. What do we do after the container of this demand is done? I can trash in the trash? No. What do we have to do? According to the label here, we have to do the triple rinse. Okay, so how the triple rinse is done? We basically fill the container of the pesticide 1/4 full with water and recap, shake for 10 seconds, and pour the rinsate inside of our sprayer. Or if you're not going to use right away, you can put in a container, label properly, and then reuse. Drain for 10 seconds, and then we're going to do this process 3 times. Full 1/4, shake for 10 seconds, put on the sprayer, fill with water, close, shake for 10 seconds, put it inside of the sprayer. So I did that 3 times, and after I did that, we're going to do perforations, poke holes on the container, and bring bring it back to where? To our office so it can be properly disposed. Some of our offices will return to the provider that will deal with the disposal aspect of the containers, or other offices will send to a specific company that will do incineration of that material, and our offices receive a certificate saying that they dispose correctly the container of pesticides. Also on the label, we're going to see information regarding the manufacturer, in case you have questions. And remember that the label is the law. Every single service car that we have in Truly Nolen should have a book containing all the labels and safety data sheets of the pesticides. And also our office must contain a book of label and SDS of all pesticides that are used in the office. Okay? Now, what is the safety data sheet? The label will contain more information regarding the pest, the formulation, the how to use, some information also regarding the personal protective equipment. But the safety data sheet is basically regarding the chemical composition, right? The hazards, first aid measures in case of accidental release. So what should we do? We're going to see on our safety training cases that we have accidental release, that the pesticide spill control. So we're going to talk about the spill control. It also contains the handling and storage, how to store the pesticide, how to transport, exposure, personal protective equipment, physical and chemical properties, stability and reactivity, toxicological information, target organs. So it's more about the safety regarding the applicator, the environment, the non-target animals. Disposal considerations: do not reuse product containers. Dispose of product containers, waste, and residues according to local, state, and federal health and environmental regulation. How to transport. The transportation of pesticides is basically done according to the Department of Transportation of each country. The regulatory information and any other information will be found on the safety data sheet. One consideration here, the PPEs that should be used. Individual protection measures. Eye contact. Use chemical splash goggles. Skin. Wear chemical-resistant gloves such as beryllium, butyl rubber, nitrile. We always recommend nitrile rubber or Viton. Inhalation. A combination of particle organic vapor should be used until effective engineering controls are installed to comply occupational exposure limits. So basically, use a NIOSH approved respirator with an organic vapor cartridge. We're going to see more details, the types of respirator in our safety training, but it has to be a cartridge that protects the applicator against organic vapors. Okay, it's a carbon filter. Now, last but not least, let's talk about our safety. So we talked that there are pesticides that have a higher or lower toxicity, but what does toxicity mean? Toxicity is a measure of how poisonous a substance is based on acute toxicity and chronic toxicity. What is acute toxicity? It is when we get exposed once or a short period of time towards the substance and we get sick. toxic. You get sick. And chronic, which is our main concern, is when throughout the time, different exposures, our technicians get in contact with a pesticide that contains maybe a lower toxicity, and throughout the time, they get sick. That's what we call chronic toxicity. So the toxicity is actually calculated based on the lethal dose to tell if a pesticide is more or less toxic. There is an experiment done in laboratory before the release, before distributing a pesticide. It's a study on the lethal dose 50, which also is, you're going to see on the label sometimes as LD50. So the LD50 is the amount of active ingredients required to kill 50% of a group of pest animals. So it is expressed in milligrams per kilogram of body weight. So it's expressed in milligrams of the pesticide, the active ingredient, per kilo of the animal tested. So let's say that we're going to see an experiment done in laboratory for a pesticide. So before distributing this pesticide, they do the LD50 test. They put 100 rats. Let's say that these rats have 1 kilo, each one. And they're going to apply the pesticide on the skin of each one. Let's say they're applying 200 milligrams of the pesticide, and from 100 rats, only 10 died. I didn't reach the lethal dose 50 yet. I have to kill 50%, so it should be 50. So 200 milligrams is not enough. So okay, let's do another experiment. Let's put other 100 rats with 1 kilo each, and now we're going to increase the dose to 600 milligrams of pesticide on top of their skin and see how many we kill. Okay, with 600 milligrams, we killed 50 out of 100 rats in the laboratory. That means that we reached the lethal dose. We found for that pesticide that's going to be distributed that the dermal lethal dose is 600 milligrams per kilo. So that's the lethal dose, 50. We also, according to the World Health Organization, they also use the oral lethal dose 50 to categorize a pesticide if it's higher, the toxicity is higher or lower. Okay? So, when you're looking at the label of a pesticide, if you see higher numbers for LD50, so 1 kilo, 5 kilos, so 5,000 milligrams is the lethal dose, that means that they are less toxic. If I have an LD50, a small number for LD50, let's say it's 50 milligrams per kilo, so it's required only 50 grams of the pesticide to be ingested or in contact with the skin to actually kill the pest. That's very toxic. Think of if it was poison. If it's requiring just 1 droplet for you to ingest of that poison to kill you, it's very toxic. So a low LD50, more toxic. But let's say it is a poison and I drink it, but I have to drink 1 gallon, a liter, 3 liters of the pesticide, it's less toxic. It requires much, much more of the active ingredient to actually kill. So it's less toxic. So based on that, World Health Organization created this table to classify pesticides according to their toxicology. Class 1, as I told you before, the color red on the label that some countries follow, the signal word on the label will be danger, poison. They have an oral LD50 of less than 50 milligrams per kilo and dermal less than 200 milligrams per kilo. And they're considered class 1. Then we have class 2, Color on the label, yellow. Word, signal word, warning. 50 to 2,000 and 200 to 2,000 milligrams per kilo for LD50s. Now, as I told you guys before, Truly Nolen uses pesticides in class 3 and class 4. Do you remember the class of the demands that we just saw? Class 3. So it was saying group 3 insecticide. That means on the label that they are here. Class 3, more than 2,000 milligrams per kilo is the LD50. So more than 2 kilos per kilo is necessary to kill a person. So word on the label will be caution. So there's lightly toxic. In class 4, generally cause no harm, more than 5,000 milligrams per kilo. The word will be caution, and the color on the label will be green. When dealing with pesticides, attention! The risk of intoxication depends mainly on your exposure over time. Meaning, if I have a pesticide that is low, the toxicity is low, but we're not wearing our personal protective equipment, what will happen? You're going to be exposed to that pesticide, get in contact, inhale, ingest, and your risk of getting sick, intoxicated, will be high. Now, if I have, for example, a pesticide that contains high toxicity, which is not the case of Truly Nolen, but just so you know, and the exposure was low, we're wearing our PPEs, doing the application according to the label, what is the risk of an intoxication? Low. So keep that in mind, that the exposure, the risk of intoxication depends on exposure over time. Now, signs and symptoms of pesticide poisoning. Somebody got intoxicated, got sick. Signs are what other people will see when the person is intoxicated, has pesticide poisoning. Person that is intoxicated will be vomiting, sweating, will have dilated pupils, convulsions, coughing. And symptoms is what you're going to feel if you have an intoxication, a pesticide poisoning. So you're going to feel headache, weakness, dizziness, nausea, skin, eye, or throat irritation. And if you're feeling that and you're not wearing your PPEs, your answer is wear PPE to protect yourself. But in certain cases, we may see people wearing the personal protective equipment and getting sick. Why? Sometimes because they're not putting their mask, the respirator, or using the correct filters and inhaling this pesticide. In our following training on safety, we're going to explain how to attach properly the masks to your face and the correct filters. Okay? So keep in mind, your safety is important. Use the correct filters. What to do in case a person has pesticide poisoning? Stop the victim's exposure to products. Put them in an open area, ventilated area. Call a doctor or an ambulance. Apply first aid according to the label, and if you receive training, proper training for it. And call poison center if your country has one. Safe products label to present to the doctors, because a lot of times there is the antidote and what to do on the label for the medical personnel to address the situation. So how do we reduce the exposure with risks to pesticides? Know how pesticides enter your body. It could be through your skin. And attention guys there, especially the guys. You know which parts of our body absorb more rapidly, way more rapidly, the pesticides? One of them our groins. So if you're not washing your hands after application, and by any chance you got in contact, the pesticide got in contact with your hand and you went to the bathroom, when you're going to the bathroom, get in contact with your groins, absorption, and you can get intoxicated. Through our hands, through the face, the skin, and our feet. Sneakers is not the correct personal protective equipment for our feet. There are special boots, impermeable, hydro-repellent shoes specific to prevent absorption of the pesticides. And feet also absorb pesticides quite quickly. And imagine, you got some spill of pesticides on your sneaker, which you should not be wearing. And then you're wearing it every day. You didn't wash it. You're getting exposed daily to that pesticide. Attention there. Inhalation. What are our masks for? To be used. We have dust masks depending on the pesticide. We have full masks. We have half masks. We have different types of filters. And in a lot of cases, it will be required the carbon filters, the cartridges against organic vapors to prevent intoxication. Oral. I'm going to pinch ears for those that are smoking with your gloves on and ingesting pesticides. Once I saw a person doing an application without gloves, so they're getting dermal exposure, and this person chewed their fingernails. Terrible. They're ingesting as well. This person was ingesting. Always wear your personal protective equipment. So nitrile gloves when we're applying pesticides when required on the label. Okay? And ocular, our goggles, face protection, the shield, sometimes is necessary to prevent a dermal and ocular exposure. And if by any chance, pesticide got into your eye when you're doing the mix without your goggles, because you should be wearing your goggles when you do the mix. Pesticide got into your eye, what should you do? According to the safety data sheet of a lot of pesticides, you have to rinse that eye for at least 10 to 15 minutes with water to remove any residue of pesticide in your eye. And, as I said before, use your personal protective equipment required on the label. The label is the law. Sometimes the label will be requiring what? Long sleeves to protect the arms, the skin. Eye protection. Can we use prescription glasses as eye protection? No. There are specific goggles that will give protection on the top, side, bottom of the eyes. Respirators with the correct filters. Safety training, we're going to talk in details about these, okay? Gloves, nitrile gloves. The latex gloves, guys, do not protect against a lot of formulations we use. They are mainly to prevent a person to get in contact with microorganisms and certain solutions. So gloves, we should always wear the nitrile, the Hulk one, the green one, so the nitrile gloves. Boots. Sometimes it's necessary toe protection when we're going to lift a lot of heavy boxes, maybe sewage lids. We don't want you breaking your toes, or even your feet. So the toe protection will protect you against that. And in certain customers, it will also be necessary because it's part of their norms. Everybody that's inside of the factory, it's required. Hats. Hats are going to be used when we're doing services in crawl spaces, attics, confined spaces, customers, construction sites. Certain customers require you, just like the boots will require the hats. And remember that the boots should be water repellent. So the pesticide cannot get to your skin. There are specific protection boots for applicators. Mariah, I don't need a hat. Why do I need a hat? So I'm going to go do an inspection or even a service in a confined space. Yeah. Think of Mariah here. I'm a very small person. And I may not need, okay, what happens if there is a nail in some area and I stand up and I cut my head? I'm going to get hurt and I won't look professional to my customers. So be mindful of that. Or you're walking through an area where there's a construction site and somebody's like, oh, look at the rock, careful, boom, on your head. It's always good to be preventative. And ear protection, if you're dealing with loud equipment, you're drilling for subterranean termites, you're using a thermal nebulization equipment, they're very loud, so wear your ear protection. Thank you, everyone, and see you in our next training, safety training. Bye.